Hi, this is Jeremy Howard from Answer AI, and today I've got a little video in which I'm going to explain a bit about how HTMX swaps work. This little video will start with the assumption that you already know a bit about how HTMX works, so it's not for beginners. I want to get into the detail particularly of how out-of-band swaps and regular swaps kind of combine. So let's start with what we see on the screen here. We've got three divs, first, second, and third, which you can see in the HTML. So each one's just got an ID with first, second, and third. And I've got a button which is going to do an HX get. It's got an HX swap after end, and it's going to target the first div. But there's going to be some out-of-band swaps as well, so let's have a look at what happens when I click. Okay, so let's go in and find out what just happened. In order to do that, we're going to have a look and see the response we got back here. Maybe we'll pop this over on the side. So remember that we targeted the div called first, and you'll see that in the response that we got back, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 HTML partials. So you can see that these bunch of kind of DOM elements of these bunch of tags are not wrapped in anything like HTML or body or div. This is totally standalone, this is totally standalone, and so forth. So each of these is a separate HTML partial. So what HTMX is going to do is it's going to grab the HTML partials and put them where you asked we put them, and we asked to put them after the first div. And so this is right here they are after the first div. And we can see that if we inspect, here is the first div, and after it we have those two partials we just looked at. What about all these though? These are all different because they have a special HX swap OOB. So HX swap OOB does an out-of-band swap, and that means that they don't go where the caller asks them to go. So rather than going after the end of the first div, they're going to go wherever we've asked them to go. And so this can take any HX swap value. So HX swap OOB can take any HX swap value. And so one of those is after end, which inserted after the target element. But in addition, you can also add a colon and a CSS selector, and so that means it's going to be swapped, in this case, after the end of this CSS selector, which we've set to hash first. So let's pick one that's pretty straightforward here. We'll go down to thing G. Thing G has been swapped before the end of the second div. And so you can see here is thing G. And if we then have a look at the elements, you'll see that thing G, here it is indeed before the end of the second div. Okay, now clearly there's a lot of details, though, about how all these are combined together. Because, for example, we have three OOB swaps that all target the same thing after end first, C, D, and E. and they end up in reverse order. Furthermore, they end up after A and B, which were the non-OOB swaps. Why does this happen? So to understand exactly what's going on here, we have to understand how the HTMX swap algorithm works behind the scenes. So here's how it works. It grabs all of the partials, and it first goes through each of the OOB partials. So it goes through each of the OOB partials. And it goes through them one at a time in order. So the first OOB partial it finds is this one, which says put thing C after the end of first. So it goes after the end of first, and it puts thing C after it. So initially, it's going to be right here, just after div id equals first, it's going to put thing C. Then it's going to do the next one. So it's going to put thing D immediately after the end of first. Now remember, we just put thing C there. So when we put thing D immediately after the end of first, it's going to be above C. And so that's why you end up with D above C. And then it's going to go ahead and do the next one, which is E. And it'll put that immediately after the end of first, which is going to end up being above D and C. And so that's why you have this in order. Reverse order. And it'll go to the next one. And it'll say, oh, and then the other thing you might have noticed is this div here has disappeared. So this P, thing E, is appearing on its own. There's no div around it. Why is that? That's because, as it says in the documentation, if a swap value is given, which we give it after end : hash first, that's what strategy we used, and the encapsulating tag pair will be stripped. So in this case, that's the div. The div will be stripped, unless it is swap outer HTML. And by the way, swap of outer HTML also has a synonym, which is true. True means outer HTML. So in this case, it's not true or outer HTML, and therefore the encapsulating tag pair is stripped. So we lost our div, and the insides of that then were placed in this location. So then it goes to the next one, the next OOB swap. And here it says, okay, this time the swap OOB is inner HTML, and that is not outer HTML or true, and so therefore the outside's going to be stripped. And this is basically just the same as putting : second. So this is saying where it should be compared to. So you might wonder, well, why do we have : at all? Well, that's because you could put other types of selector other than an ID here. Besides which, I guess this is actually a little bit more concise. But these are basically the same, except this one here is going to replace the inner HTML of second. So let's go and have a look for thing F. Here's thing F, and you can see indeed that replaced the contents of div id second. Initially it was empty, now it's non-empty and contains thing F. Okay, next up, another OOB swap. This is before the end of second. It's going to put thing G. So it's going to go, okay, before the end of second, it puts thing G. And then ditto for thing H before the end of second. And so because we're using before end, that's going to put it beneath G, because that's before the end. So before the end ones are going to end up in the same order you provide them, whereas after end ones will end up in the opposite order to how you provide them. And it's just this side effect of how the HTMX swap algorithm works behind the scenes. Okay, so that gives us GHI. And then finally, J, we have not wrapped in a div. And that's because we've used HTMX swap OOB equals true, which is the same as outer HTML, which we were told means for other than HTML, outer HTML, we remove the encapsulating pair. Well, this is outer HTML. So we don't remove the encapsulating pair. And so therefore this one is placed in directly, and it's going to replace ID equals third entirely. And so here it is. There is no div ID equals third. Instead it says P ID equals third. That's because we've replaced it entirely. So now that we've gone through all of the OOB swaps, so they've all been dealt with, finally, HTMX grabs all of the non-OOB swaps at once, so it doesn't go through one at a time, but grabs them all at once and dumps them all wherever you ask them to go. And the place where we asked them to go was after the end of first. So therefore, we see thing A and B dumped together after the end of first. And so that's why these are in order. They weren't done one at a time, but they were all dumped in at once. Okay, so hopefully that has now given you a reasonable sense of why this particular bunch of HTML partials are swapped by HTMX into the locations that you see here. If you want to play with this yourself, you can go to the FastHTML example repo, and there you'll see there's an HTMX folder, and there you will see there is an OOB.py. And this is the single file program that runs what we just saw. You can see here we've got our /link, we've got our button. Those are the three divs. When you click on the button, it has the hx target, hx get, hx swap, and here are those various HTML partials popped into a tuple. That's how fast HTML does them, including the div with the P's inside, the OOB strategies, and at the end we've got the hx swap OOB true. So that is in the fast HTML example HTMX folder, OOB.py. Okay, I hope you all find this helpful for understanding how HTMX swaps really work.